In this episode, I'll show you how to build an Azure lab with Terraform. We'll walk through how you get started, how Terraform works, and then I'll run through an actual demo as well to show you the commands and how it operates. I've also got code in GitHub, which you can just clone and get started as well. And there's a bunch of scripts to make your life easier as well. Hi, I'm Sunny. And I'm your host. Oh, that was close. And welcome to Someone Else's Cloud. Hi, I'm Sunny, and I'm your host, and welcome to Someone Else's Cloud, a video podcast about Microsoft Azure where we discuss all things cloud computing, DevOps, and my experiences as a consultant in cloud engineering. This is episode 4, and today I'll show you how to build an Azure lab with Terraform. So what is Terraform? So Terraform is an infrastructure as code tool that's developed by a company called HashiCorp. If you used ARM templates in the past, they can be quite cryptic. Terraform is actually declarative. So you basically declare what you want and your target end state, and that's what it's going to build. It uses something called HCL, which is HashiCorp configuration language. The key benefits of using Terraform is it's a single language that you can actually use to consume Terraform providers for different clouds and use that universal sort of language to develop solutions or build solutions, across different clouds. I think it's a skill that's probably in demand in the industry at the moment because there's a lot of initiatives in the industry around multi-cloud. I like Terraform. It's a bit simpler. I've been using Terraform for probably over a year now at work. It was a steep learning curve coming from someone that just hacks PowerShell scripts. It is a steep learning curve, but once you understand it, it's quite straightforward. It does have its little quirks, which can catch you out. An example is when you're changing from Azure RM providers, it is documented, but can be breaking changes where if you're dependent on certain attributes, especially that are embedded inside modules, it gets a bit tricky when those attributes disappear. So in short, I do like using Terraform. It is a lot simpler than ARM templates. Back in the day when you had ARM templates and you'd create PowerShell wrappers, but the ARM templates would have static values. I do like that Terraform is a bit simple. It's declarative. You can look up resources and consume attributes in them. You can also create objects and consume them throughout the module. So kind of makes your code a lot easier to template. You can create something like a configuration file that just gets consumed through variables through your code. So that's definitely something that I've adjusted to. Let's get started with the Terraform overview. So providers are pretty much like PowerShell modules. They determine, what your resource types are and data sources are. And there's providers obviously for all different clouds. In my demo, we'll be using the Azure RM provider. File structure. Theoretically, you could put all your files into a main.tf. But as your environment gets more and more complicated, you'll find that it's easier to logically separate your file structures out or your configuration files out. If you're working in a team environment, it's easier to have a consistent structured approach. Obviously, consistency will create efficiencies. So if you are working in a team environment, it's best to have a documented standard on how things should be structured, named, and where things should go. But if you're just creating a demo, theoretically you could just create a main.tf. Workspaces, as listed on the Terraform website, is a collection of infrastructure. And pretty much it's where your configuration files will live, and as well as your state file. I'll talk about state file further down, but I won't delve much into the workspace talk. Resources are obviously the resources that are consumed through the provider. So, virtual machines, NSGs, KeyVaults, whatever else. I'll walk through that a bit later. Data sources are basically ways where you can reference objects that are not created in your workspace. An example is if you had a central key vault, you could do a data lookup to look up a key vault secret and then consume that through your code, which is what I have in my demo. Output variables are handy as well. If you've got multiple workspaces, you can basically create outputs. If you're using modules as well, you can create outputs, as well as resources. You can actually create outputs too. Pretty much My demo for the multi-deployment code consumes outputs from other workspaces because I created a central hub. And yeah, so outputs basically allow you to output attributes from resources, and you can consume them through a data source lookup. Local values. A local value assigns a name to an expression. So you'll see in my code example, I fabricate names as well as shorten location names, which I consume through the code. So then that way I can create an overarching locals at the top and then consume them through the code. So it kind of makes it a bit easier rather than having to change every, say, VM name. I can just put a local reference to it and then have a single value that cascades through. Modules are pretty much containers of multiple resources that are used together, is what the description is on Terraform. The easiest example is obviously a virtual machine module, which groups a whole bunch of resources together. An example is you need to have a virtual machine. You would assign a network interface, potentially a public interface, and you would deploy agents and configure them. So you could wrap that into a module, have a input value, I guess, or parameters where you can insert certain values that are required to execute those, and then pretty much consume that module. It's kind of like a pattern of resources, I guess. So it's like a wrapper around an ARM template, I guess, where you can put in input variables and then have desired VMs which will consume those parameters and include them in the build. So input variables I just covered. Input variables are generally parameters for Terraform modules. So state files. So Terraform stores a snapshot of your environment in a state file. If you look inside it, it's actually a JSON file. But every time you make code changes, it refreshes. Terraform will refresh the state file and do a comparison on what your code wants to do against what's really out there. And then it'll basically show you the changes that you're planning to make. You can modify the state file directly, which is probably not something recommended, but there are times, as I mentioned before, changing providers with breaking changes, and you've got certain attributes that are in a module that are no longer used. Sometimes there's no other way to remove them. Definitely, I would try to remove them through code first. But yeah, state files is not something you want to play with, or if you do, take a backup first. Terraform commands, the common ones will be a Terraform init. So an init will initialize your local workspace. So you'll download all your modules and your providers and set up your local workspace so you can do a plan and an apply. So a plan will pretty much execute your code against the current state, against the state file, and it'll tell you exactly what it'll do. Generally, it'll show a green plus for an addition, a tilde for an update in place, and a red minus, which is generally a destroy. An apply is pretty much going to apply it. So it actually runs a plan first, and then it will ask for confirmation. Then once you've confirmed, it will actually apply. And a destroy is obviously going to destroy. There's other commands that you can run. So validate, which will actually check the syntaxing of your code. FMT, which is to format your code. So it's like a linter. And yeah, so that's pretty much, in short, Terraform. So let's just switch over to the demo. Obviously, you need an Azure subscription to get started. So how you can prepare your environment. So you need a service principal, and you're going to need the certain permissions to do whatever you need to do. So I've got a script that I've slightly modified from the internet, which will automatically just run. You'll create a service principal. You'll assign contributor rights to the subscription level. Just make it easier so you can deploy whatever you want. There's also a second script, which will install Terraform and configure it. So you need to run that as a local administrator because it makes system changes to the path. So you can run Terraform from anywhere. It's pretty cool. The script, it basically goes to the download site in Terraform and finds the latest, and then it downloads it for you and then sets it in your path. And then once you've done that, the first step, which is the create service principal, that will provide outputs that you can just put into your Azure RM provider for Terraform. We'll run through that now. So if you go to the repos, go to GitHub, github.com/someone else's cloud, you'll see that there is a episode 4 repo. If you open up the repo, you'll see I've got a rundown on what the scripts do, and the single deployment and the multi-deployment, which are stored in the labs folder. We're only going to talk about the single deployment, or I'm only going to demo the single deployment, but I will show you some different things in the multi-deployment, but I won't demo them. So once you get a gist of the single deployment, you can have a play around with the other deployment. So let's get started. Clone the repo using SSH. HTTPS should be available as well. So if I just go, this works. So just going to clone this repo. So once I've cloned it, what I'm going to do is I'm going into the lab folder, and I'm going to go to the single deployment. So as you can see, single deployment. But what I'm going to do is find this script. So this create TF script, and I'm just going to copy the path and run it from here, and show you why. And now, yes, it's using Azure RM. Yes, outdated, but it works. So just going to log in. Oop. Having a long name, that's fun. So this will go through and create it. Let's log into the Azure portal. So while this is running, there is a sleep for 15 seconds, which is waiting for service principal to appear in the directory before it assigns a permission. Just a preventative, I guess. Okay, so you can see it's assigning the role. Hopefully no errors, no. And okay, so this little output here is what you need for your providers. You can copy the whole block, but my code already has the block there. Let's just quickly validate first the role. So if you go look at subscriptions, so it should create Terraform-SPN and a random 5 number digits or 5-digit suffix. You can see here I've run it before. Now if you go back, the reason why I ran in the folder is because it creates a file name which is the service principal name, and the password is in there. Now obviously it's not really best practice. I just did it for the demo, so it makes your life easier. And obviously the client secret is actually listed here as well. So you can see that 79235, which is the second one. You can see it has contributor access. So let's go again. So let's copy this again and go set up the providers. So if you go to the lab, single deploy, and we go to providers, pretty much just copy this block in, save it. So that should be in there. So if you run, so I've got an alias, which is just TF to point to the Terraform file. But if you run that script, it will actually be Terraform, but Terraform works as well. But TF, and I just go FMT, which will lint it. If you look at it, it'll space out my file. So pretty much I've just set up the account, so that's pretty straightforward. So all I actually need to do, is just do a Terraform init, which will actually initialize it. So I'll download my files. So I'm gonna, just to save time, I'm going to run an apply, and then I'm going to talk through the code while it's applying. So I'm not going to run a plan because, as mentioned, an apply will actually run a plan. So you can see there. So let's just do yes. We'll talk through the plan later. Let's just talk through the code first. So while it's doing that, let's go look at the main.tf. So main.tf, so if you go back to the repo, it shows, I try to draw a little simple picture. So what it's going to do is deploy 2 resource groups, both with a VNet and a subnet and a storage account. and a virtual machine with a network interface and a public interface, so you can RDP to it. But in the resource group 1, I'm also deploying a labeled a KeyVault. I was going to say labeled as a central KeyVault, and a log analytics workspace, which the agents will be deployed to the VMs, and they'll basically forward their event data and insight metrics to the log analytics workspace. The KeyVault will store the local admin password and the workspace key. I've got access policy here, but I just use the default. My original code actually has my details in it, but I took it out for to sanitize before I uploaded. So this thing's creating. So let's talk about what I've done. I'm using something as mentioned in the providers file, which is a random provider. It's actually a provider. It's not a random one. It's a random generator. So you can see here. So I'm using random pet. Random pet just gives you pet names. And I'm using random shuffle to shuffle locations. So if you look at what I'm using here, I've got 2 pet names because I've got 2 RGs. And length is just 1 word. So it will randomly generate 2 pet names, which will become my unique asset value, or like customer tag, I guess. And I've got a random shuffle for locations. So I've got 2 locations just to make sure that I always get 2 locations and they're going to be different. And I've got a random password that's being generated. So it's always best practice to not store passwords in code. So this will randomly generate it, but I am outputting code, outputting passwords. So when this runs, it actually outputs the password on screen, which is not something you should normally do. It's only for the demo to make your life easier. But I do store it in the KeyVault, which I'll show you as well. So let's break down how we consume a Terraform resource. So if you look, I'm declaring here a resource, which is a Azure RM resource group, and then I'm giving that that resource object a name in my code so I can call it later. And then this is the actual naming that I'm using. So I'm using a locals file at the top, which is just a name to an expression. So it's easier to just have a short name and then put whatever you want that name to be. If you go back down, so you can see I'm consuming that local and name 1, so it'll be obviously the first pet name. And here I'm consuming the local.location ID, and because there's 2 values in the result, I'm choosing 0 for the first one in the array. And then if you go look at the code, so every example or every Terraform resource has examples, and the example always has a resource group, because obviously you need a resource group before you deploy anything, so I'm not really going to cover that. But virtual networks, so an example of a virtual network is I'm declaring a virtual network. I need to give it a name, and I need to store it. I need to build it somewhere. So you can see here that the location is referencing the resource group example above, and the location and the name, and then you need an address space. There's a whole bunch of other things, but if you scroll a bit further down, it tells you what's required and what is optional. So I know that all I need really is just a name, resource group, address space, and location. So if you look here, my name, I've fabricated a name, which is going to be the pet name, and then my location name, and then just vnet-1. And then I will consume my resource group above. So you can see here that that's why you need to give it a name, and it needs to be unique for this resource type. I just made it simpler by calling it resource group _1, and then you provide an address space, and then I'm creating a subnet which will actually consume that virtual network name. So you can see here it just tags in to this virtual network .name. If you have a look, how do I know what to consume? You'll see here that if I look down at this virtual network resource, so this is the virtual network resource. If you scroll to the bottom, there's an attributes reference, and it says the following attributes are exported. So that's how I know I can consume the name, and I know that the subnet resource requires a name, or a virtual network name to be specific, and that's how I know what to call. and obviously the address prefix needs to align with the actual subnet. So that build's done, but I'll keep on running through this first. So this is a second resource group, won't cover that. I'm deploying a log analytics workspace, stock standard as well. And then I'm deploying a log analytics solution, which is the VM Insights for insight metrics, and the dependency agent for network data. This is more, if you're building a lab, if you're doing any of the AZ 300 exams, you definitely need all this. This is just base log ingestion types, so data sources. I'm getting Windows events, grabbing some performance data, and that's it. So you have to configure those, or else it won't collect it. So this is where I've created a KeyVault. So you can see here I've just put the bare minimum configuration required. But there is this interesting part. So this is a standard call to actually grab the context of the current user being executed, which is a service principal. So if you don't have access to the actual service principal details, you can actually call it using that. So you can see here I'm adding it to the access policies, and I've extended the secret permissions because I am going to put the local admin password, so I'm creating a value there, and I'm basically grabbing that randomly generated password and storing that as the value and putting it in that key vault I'm creating above. And then I'm also grabbing the log analytics workspace, the primary shared key, and putting that in the key vault as well. Creating storage counts just for the sake of creating storage counts, but like I said, the AZ 300 exams, they will the AZ300 exams, there are a lot of questions about storage counts and replication. And I go through building a virtual machine. So I've got a network interface, which needs to point to a subnet. So I'm referencing the subnet above. And I've got a public interface, which is created below. So the later versions of Terraform, after 12, has implicit dependencies mapped, as we're in 12, you'd have to use a value called depends on, which you could use. You can make resources depend on each other. So you can make a virtual network depend on a resource group. So obviously resource group needs to be created before the virtual network. But I think in Terraform 13 Plus, it does it automatically. So you can see here, I'm going to consume this and add it. So that way I have a public interface, so I can RDP to it. And this is where I create the virtual network. So if you look at it, it's pretty stock standard. It's going to consume the network interface I create above and the randomly generated password. And then it just shows you, the image I'll consume. So it's Windows 2019 data center. And then there's other things. You can add data disk and whatever else. If you look at the VM resource, it should show you that. And then I'm deploying agents. This is the MMA agent, which is also known, I think, as a log analytics agent, using raw JSON in here to actually configure the MMA agent. So it's going to point to the workspace ID of the log analytics workspace, and then it's going to grab the primary shared key and put that into the MMA agent. And then the dependency agent, which is just required for insight metrics for networking data. I do have a depends on here. I just put that in, but I don't think I actually need it. So that it's saying it depends on the virtual machine. And that's pretty much it. So this is the second virtual machine. So my build is done. You can see it didn't take long. I find that running it in the morning, off peak, it actually executes faster. So if you have a look, when I ran this, actually I should run through the plan as well. So I ran it at 850 and it finished 6 minutes later. So that built me a whole environment. You can see the plan here. It's all plus signs because it's all creating. So this is pretty much all the code I'm running through. It's showing you that it's going to create an Azure Key Vault with the access policies. It's going to create the secrets, the data sources for the law. And yeah, so I won't run through that too much. Spend your, a lot of things also say known after apply because they don't actually get created until you actually apply them. So you'll see here that when I've actually confirmed the apply, you can see that it's created my 2 pet names. So it's going to be crow and termite. So everything's going to be labeled after those, and then it goes through and creates everything. And then it outputs the password, which, not good practice, but I did that just to make your life easier, but it is stored in a KeyVault as well. So let's go into the subscription now. So resource groups. Let's see what we've created. Okay, so we've got termite. So termite -1 is going to be my primary. So you can see here, I've got all the values here. So that's everything that they got created. Sorry, I'm trying to rush now. I've got a little heat lamp on my screen there on the camera, so it's going to potentially shut off. Let's go into access policies. So I just need to quickly add myself. Oh, this is not recording. OBS stops for some reason. I don't really like OBS. I don't know when that stopped recording. I might have to run. If I just add myself again. That's the second time it stopped recording, which is why I'm shooting this again. Trying to shoot it before work. So we're just going to save that. So I've just added myself, so I can see the secrets. And you can see that I should have 2 secrets. So if I go into local admin, show secret, you can see here, PHJ4 should be PHJ4. Yep, so let's go back to this. Okay, so that's there. Let's go into the Log Analytics workspace. I don't really trust the interface on showing me what's reporting. I'd rather just ask it. So we'll just check out a heartbeat. We can probably just round it off to just computers. So it should be 2 computers. Keep in mind that building this and tearing it down, it's probably best to just build and tear down, or don't forget to shut down your VMs, or else you get charged for VM uptime. So insight metrics. So insight metrics will show you all the performance data. And if I go to events will show me the events. So system and application events is what I'm collecting. So you can see here multiple VMs. Now let's go to a VM. Let's show you the dependency agent, what that will show. That's pretty cool. So we go into insights. So it shows you a lovely map, which is cool. I haven't really used it much, but it's cool. If you look at log events, it shows you the data it's sending. So event, heartbeat, insight metrics, which are the ones I just queried. These ones are dependency agents, so more networking data now. If you didn't know that was available, that's cool. So that's pretty much it in the demo. One thing I'll talk about is the second example. So multi-deploy Terraform. Actually, while we're doing this, I'm going to destroy the environment just to show you. So TF destroy. It will also ask for a confirmation. Yep. So let's go yes. And so they'll start destroying. So multi-deployment. I've got 4 different folders. So I'm actually creating a hub and a spoke. So a hub meaning that it's more of a platform services are stored there. The reason why you would have multiple workspaces is potentially to separate segregation of duties. So every workspace will execute under a different service principal context. So you could obviously assign lower privilege ones to the spoke, which is what we do at work really. So you can make the spoke only be able to build VMs and that's it. Can't create virtual networks, but you can consume outputs from other workspaces. So that's what my code does. So I try to put everything into this hub one, and then all these other workspaces actually talk to it. So if you look through the code while this thing's destroying, multi-deployment. So if you go look at the hub, And spoke, there's different files, but what I wanted to show you is this is pretty much the same code I ran through. I just split it up, but I do have outputs. So this is outputting all the things I want to consume. So key being subnet. So subnet, I'm outputting the entire subnet resource. So if you go look at the subnet resource, you can see what's being exported again. So attributes reference. So you can see it's going to export the ID and the name and resource group, virtual network, and things like that. So subnet ID will be required to create VMs, as you saw, which is why I'm exporting it. I'm exporting the law ID. Note that there's .id. .id is the resource URI, as where workspace ID is actually the workspace ID for the MMA agent. So don't get caught out by that, because I did when I was trying to deploy the agents. And I'm outputting the entire KeyVault. So that way I don't want to be really exporting the primary shared key. So that's why I'm outputting this specific value and then the KeyVault. And then if you go to spoke 1, the data lookup shows you it's pointing to those hubs. Now this is a local reference. So it actually, you just need to point it to the other folders and where the Terraform state file is. Obviously you need to run, you need to build out the hubs before the spoke, because for these to work anyway, these files need to exist. And then if you look through my main file, so same random pet, random location, and a password, and you can see here for say the local admin password, I'm actually looking at this data reference that I created to hub 1 and consuming the KeyVault and the ID. So that's the required value to look up a secret, and the workspace key. So there's a value for the workspace key. And then you'll see the virtual network, which is hub1 outputs subnet.id. And that's pretty much how you consume, from other workspaces. So that's pretty much it. So hopefully, that gives you a bit of insight on how Terraform works. I didn't want to have long videos, so hopefully this video doesn't end up being too long. And as you can see, I am destroying this environment as we speak, which you'll see here. Should have things that are gone, yes. So yeah, it shows you how easy it is to actually build and destroy a lab. So I find it super handy. And yeah, I actually don't mind Terraform. Some people have their gripes with some things. But yeah, so hopefully that's helped. Okay, so thanks for watching. I hope this has given you some sort of insight and help you get started with using Terraform. Like I said, it makes sense to build a lab using Terraform because it's so straightforward, rather than having the old school way of a PowerShell script wrapping ARM templates. There is some talk at the moment about something called Azure Bicep. I'm yet to play with it, but it looks like I think it's declarative as well. So I'll probably do a video on that at some point. It does look quite interesting. But yeah, this is one of many tech videos to come, looking at trying to potentially get people on. So yeah, thanks for joining. Don't forget to like and subscribe to the channel. Post your comments below if there's any thoughts around, things around Terraform, I guess, that can be done better, or what you really think about things. And don't forget to follow us on all major podcasting platforms. I'd recommend you watch this one on YouTube as a demo. Hopefully I've recorded most of the video. But yeah, thanks for watching and signing out. Catch up. And welcome to Someone Else's Cloud.